All right, let's see how you did. So here we have a set of numbers, A, all these numbers, and we're trying to list which ones belong to the given set. So let's look at integers first. So if you remember, integers were the counting numbers. They also include 0, and they would also include the negatives of the whole numbers. So starting off, we've got one right here. We've got -6. That's the negative of a counting number, and so that's going to be an integer. We've also got here, that's not a whole number. That's not a whole number. Negative radical 3, no. 0 would be an integer, and we've got a decimal, we've got pi in there, we've got 10. Okay, so we're going to have -6, 0, and 10 are all integers. Okay, so now let's look at the next set. So we'll look at the rational numbers. So rational was a big set. If you remember, the rational numbers, the rational include all of these. If it's a rational, it can be written as a ratio or a fraction. It could be an integer, a whole number, or natural. So it could be all of this. Basically anything that's written as a fraction or decimal, so long as it doesn't have like a radical in there or pi or something like that. So as we go through here, we should see, okay, rational, that's a ratio, -6/1. That's a ratio, that's a ratio. Radical 3, that's not. Whether it's positive or negative, that's not. 0, that's 0 divided by anything, is 0 divided by 5 is going to be 0. 0.31, that's 31 hundredths. 0.3 repeating, because it repeats, that's 1/3. 2 pi, all right, the pi is not going to be rational. 10 is 10/1. And again, the radical makes that one not rational there at the end. So we've got -6, -12/4. And you might be thinking with this -12/4, now wait a minute, 12 divided by 4 is equal to 3. So what does that mean? Well, it means that we're going to have to think about what set that belongs to and if we maybe missed something. So we'll kind of keep our eye on that as we come back to that. So rational, we'll get rid of those, and we'll keep thinking about that 12/4 and what that means. All right, so next let's look at irrational. So that cannot be written as a ratio, so we've got this radical, that one, plus the 2 pi. So we're going to have negative radical 3, we're going to have 2 pi, and we're going to have radical 17. And last of all, we're looking at the natural numbers. So with natural, we're looking at just the counting, 1, 2, 3, 4, 5, 6, and so on. And as I look through, there's only one, 10. If I counted up there to 10, I would reach, right? Before I reach the end of my fingers, I would reach number 10 on the natural numbers. So the only thing left is to go back and think about this -12/4. What is -12 divided by 4? That's -3, which is an integer. So that's actually as well an integer. I could write it as -3, which is the same as -12/4. So that would belong to that set. So that one can be a little tricky. All right, and then 2 is just a separate one. It says give a number in decimal form for that belong. Oh, I've got a typo here. Everybody cross out that 4. So give a number in decimal form that belongs in each set. So a decimal number that's rational, okay, that would be any decimal that either terminates, so 0.25 or 0.5, or it could be something that repeats. 0.1 repeating, 1, 1, 1, 1, 1, or 1/9. That is a rational number. This one is 25 hundredths, or we know that's a quarter, 1/4. This 0.111 repeating is equal to 1/9. And then irrational in decimal form, well, we cannot write the entire irrational number in decimal form. So it could be 4, 3, 5, 1, 4, 5, 2, right? It does not have any pattern that continues and it doesn't terminate. So there'll always be kind of a dot, dot, dot here at the end of the irrational set. All right, so let's move on, and we've looked at the number sets. And so the next thing we need to do is look at the Cartesian coordinate system.